Assalamualaikum. Hi guys. We are going to learn about basic molecular shape in this video. There are 5 basic molecular shapes that I want to introduce to you. First one is linear. Second is trigonal planar. Third is tetrahedral. Fourth is trigonal bipyramidal. And the fifth one is octahedral. So these 5 is the most basic. And you have to know how to draw the structure for this basic molecular shape based on the molecules given. First thing first, in order for us to draw, I mentioned about 3-dimensional drawing. Awak dah belajar cara untuk draw the orbital dalam chapter 2 dalam bentuk 3-dimensional drawing on paper. So same goes here. We are going to learn how to draw the basic molecular shape based on 3-dimensional drawing on paper as well. So in that case, I'm going to introduce 3 different types of bonding pair that you can draw in your 3D molecular shape. So this drawing is a method of representing the 3-dimensional structure of a molecule in which a simple lines represent the bonds in the plane of image, just like these two. So the simple line, only one line that you usually lukis, satu line. So ini untuk tunjuk in the plane of the page. Next, we got wedge shape. So this is wedge shape to represent that the bond towards the viewer. Maknanya viewer tu kita, dia nampak dari pandangan depan. So the dashed lines here represent bonds away from the viewer. Maknanya bond itu ke belakang ataupun jauh daripada pandangan depan kita. So this is how we are going to draw our structure based on wedges and dashes in 3-dimensional structure of a molecule. Let's go to the first basic molecular shape. The first one, untuk basic molecular shape, semua yang 5 saya mention dalam slide sebelum ni adalah di mana central atom for that molecule tidak mempunyai lone pairs. So maknanya basic shape tidak ada lone pair at the central atom. So I got this example where A is my central atom and B is my terminal atoms. So I got 2 terminal atoms, and in this case, for us to determine the type of molecular geometry, we have to take a look at the central atom. So at the central atom, for this case, you got 2 bonding pair and you got lone pair is 0, tak ada lone pair untuk sekeliling A. So the total electron pair should be 2 plus 0 equals to 2. And then, what I can illustrate from here, I can determine the class. The class ataupun general formula iaitu AB2. Kita ada A dan B sebanyak 2. And, bila kita dapat this class, maknanya basic shape dia adalah linear. And the molecular geometry stays the same, which is linear. Kerana A tidak mempunyai lone pair. And last but not least, you got the bond angle. Bond angle adalah antara satu bonding pair kepada satu bonding pair yang lain. So, between these 2 bonding pairs, you got the angle is 180 degree. So, ini adalah cara saya illustrate untuk linear shape for the molecules given. Now, macam mana saya nak lukis dalam bentuk on paper? I will draw it like this one, di mana we got 1 bonding pair at each side. And then, jangan lupa label the bond angle. So, let's try one example based on linear. I got example 1, BeH2. First thing first, tips dia adalah kita perlu draw the Lewis structure first. So, I'm going to count all the valence electrons in all atoms here. So, I got beryllium, which is in group 2. So the valence electron is 2. Be equals to 2 electrons. And after that, I got 2 hydrogen equals to 2 electrons. The total is 4 electrons. And after that, I'm going to draw my Lewis structure. Be is my central. I got 2 bonding pairs because 2 hydrogen atoms. So 4 minus 4 electrons, we got 0. So this is the Lewis structure for BeH2. So at the central atom here for beryllium, the bonding pair is 2. And then I got no lone pairs, so 0. And after that, total electron pairs, TeP, is 2 plus 0 equals to 2. And the class will be AB2 because we got A, our beryllium, and B, we got hydrogen, 2 of them. And then basic shape should be linear and the molecular geometry is linear. And the bond angle is 180 degree. So now we are going to draw the correct molecular geometry, which is the same one, but right now with bond angle. So I'm going to draw in this case with 180 degree for the bond angle between two bonding pairs surround beryllium. So this is the molecular geometry for BeH2. This is the Lewis structure for BeH2. So untuk kes ini awak memang tak nampak sangatlah perbezaan dia sebab drawing dia masih lagi sama. But still you have to draw both of them because you got 1 mark for the Lewis structure and 1 mark for molecular geometry. Let's go to the second basic molecular shape, which is in this case is trigonal planar. Masih lagi central atom tidak mempunyai lone pair. So I got at the central atom bonding pair is 3 and lone pair is 0. The total electron pair should be 3. The class is AB3 and basic shape is trigonal planar. And the molecular geometry stays the same. The bond angle is 120 degree. This is how the illustration for trigonal planar based on the molecules given. But kalau saya nak lukis macam mana saya nak lukis, saya akan lukis based on class dia. I got A as my central atom and B is my terminal atom. Dan jangan lupa I got my bond angle here between any bonding pairs that you want to pick. So the close one lah. Kalau you nak label dekat belah kiri, boleh daripada sini kepada sini. Kalau you nak label daripada bawah pun boleh daripada sini kepada sana. Sama sahaja untuk all bond angle. Let's try example 2. I got AlCl3. So AlCl3, we are going to draw the Lewis structure for AlCl3. So Al is group 13. So I got 3 valence electron. And then Cl, I got 3 times 7 valence electron. You got 21 electrons. So the total will be 24 electrons. And after that, Al will be my central atom. And I got 3 bonding pairs because 3 chlorine atoms. So you use up already 6 electrons. So what's left is 18 electron. And after that, each of them will get another 6 electrons for the terminal atom, our chlorine atoms. So that's why you got 18 electrons used up for the terminal atom. So minus 18 electrons, you will have 0. So this is the Lewis structure for AlCl3. So inilah tips yang kita perlu buat. The first one. After that, I'm going to take a look at Al. So at the central atom, bonding pair is 3. You got 3 bonding pairs. After that, lone pair dekat bahagian aluminium, tak ada, so 0. Next, total bond electron pair akan jadi 3. After that, class akan jadi AB3. Basic shape is trigonal planar. And molecular geometry stays the same because there is no lone pair. And the bond angle is 120 degree. So macam mana saya nak draw molecular geometry sekarang? I will draw in form of trigonal planar di mana I got my Al bonded to Cl in 120 degree. Dan jangan lupa dot simbol untuk setiap chlorine yang awak ada. And last but not least, you have to label the bond angle. So I'm going to take it from here to here. This is 120 degree. So kalau awak lihat, baru awak nampak lah perubahan dia, macam mana Lewis structure daripada this form, dia bertukar kepada molecular geometry. Syarat dia adalah daripada kita tentukan dekat central atom berapa bonding pair, berapa lone pair, apakah kelas dia dan basic shape with its bond angle. So that's all for trigonal planar. Let's continue with tetrahedral. So tetrahedral, at the central atom we got 4 bonding pairs, 0 lone pairs, and the total electron pairs is 4. The class is AB4 because we got 4 bonding pairs. And then basic shape we call it as tetrahedral, and molecular geometry stays the same because there is no lone pair at the central atom, and the bond angle is 109.5 degree. In this case, this is how we illustrate based on this drawing. So, macam mana saya nak draw dalam bentuk on paper? This is how you draw. Kalau lihat, dia punya bentuk for this one, dia macam A bonded kepada B, macam trigonal planar. Tapi untuk the fourth bonding pair, dia sengit sikit. Sama ada sengit ke kanan ataupun kalau awak nak draw, sengit ke kiri pun tak ada masalah. Macam this one. Dia sengit ke kiri. Lukis dulu untuk trigonal planar and then awak nak lukis sengit ke kiri. So, dua-dua diterima. Tapi dia kena tunjuk sengit sikit. A bit slanted. Because the angle is 109.5 degree. Not 120 anymore. So let's try one example. So this is CH2Cl2. So I'm going to calculate all the valence electrons to draw the Lewis structure. So we got carbon 4 and we got hydrogen 2 of it. So that's why I got 2 electrons. And then 2 chlorine means 14 electrons. And then total up everything, I got 20 electrons. And then my central atom should be carbon. So carbon bonded to 4 atoms. 2 of them is hydrogen and another 2 more is chlorine. So now I use up already 8 electrons. So baki saya tinggal 12. And then I'm going to put 12 of them around my terminal atoms. Dalam kes ini untuk chlorine lah sebab hydrogen sudah duplet. And then I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I use up already 12 electrons. The total should be 0. So this is the Lewis structure for CH2Cl2. After that, we are going to determine how many bonding pairs we have for carbon. So carbon ada 4 bonding pairs around it. And there is no lone pairs, so 0. The total electron pair is 4. So bila 4, kita akan dapat kelas dia AB4. Next, basic shape for AB4 is tetrahedral. Molecular geometry also stays the same. And the bond angle is 109.5. So now I'm going to draw this structure in the correct molecular geometry. I start with carbon. Bonded to in plane. Dalam in plane saya akan ambil terminal atoms yang berat. So chlorine lebih berat daripada hydrogen. That's why chlorine akan berada in plane. And after that, the rest of it, wedges dan juga dashes akan diwakili oleh hydrogen. And then jangan lupa dia kena sengit sikit. And then this is how I draw my molecular geometry for CH2Cl2. Dan jangan lupa dekat bahagian chlorine you got 3 lone pairs. Okay, you have to draw in your drawing as well so that you got the correct molecular geometry. Last but not least, don't forget we have to show the bond angle. So saya akan ambil daripada sini kepada sini. So you got 109.5 degree. So you got the correct structure for CH2Cl2, which is tetrahedral. Next, we go for the second last basic molecular shape, which is at the central atom you got 5 bonding pair, 0 lone pair. So the electron pairs is 5. So bila 5 bonding pair, the class will be AB5. The name of the basic shape is trigonal bipyramidal, and the molecular geometry stays the same with its bond angles. There are two of them, 90 degree and 120 degree. So this is how the illustration, but kalau kita nak lukis dalam bentuk on paper, I will draw it like this. So this angle merujuk kepada 120 degree and this angle merujuk kepada 90 degree. Let's try one example. I got AsCl5. So AsCl5, arsenic is in group 15, so 5 valence electrons. After that, we got 5 chlorine, means that 5 times 7 electrons. So you have 35. The total will be 40 electrons. So in this case, we are going to determine my central atom should be As, and I got 5 of it, and after that bonded to Cl, and then you use up already 5 bonding pairs, means 10 electrons, so minus, you got 30 electrons left. After that, we are going to put the lone pairs around the terminal atoms. So I got each chlorine with 3 lone pairs. So this is already used up 30 electrons. The remaining should be 0. So this is the Lewis structure for AsCl5. Now at the central atom, my arsenic, I got 5 bonding pairs here, and then I got 0 lone pairs. There is no lone pairs around arsenic, and after that the total electron pair should be 5. So the class for this one will be AB5. Basic shape is trigonal bipyramidal. The molecular geometry stays the same. Now I'm going to continue how to draw the molecular geometry for this one. So we are going to start by drawing the central atom. So my central atom is As, and then I got 3 bonding pairs macam huruf T, and then another 2 more dash and wedges. And then jangan lupa lorek untuk wedges. And then each of them bonded kepada chlorine. And then after that, kita akan letak lone pair for each chlorine. Each chlorine got 3 lone pairs. So this is how my drawing. And last but not least, don't forget to label the bond angle. So here is 90 degree, and then here is 120 degree. So this is the molecular geometry for AsCl5. Let's go to the last basic molecular shape, which is at the central atom. You got 6 bonding pairs and 0 lone pairs. So the total electron pair should be 6. And the class is AB6. And the name of this basic shape is octahedral. And the molecular geometry is octahedral as well. And the bond angle is 90 degree. So how am I going to illustrate that? This is how the molecules looks like in octahedral shape. But on paper, we are going to draw it like this. And between each bonding pair, you got 90 degree for the bond angle. So let's try SF6, where the Lewis structure for SF6, we are going to count all the valence electrons. So I got sulfur, 6 electrons. 6 fluorine means that 6 times 7 electrons. So we have 42 electrons. And the total will be 48 electrons. Next, let's do the Lewis structure with sulfur as the central. And I got 6 of it. 1, 2, 3, 4, 5, 6. And then bonded to fluorine, 6 of them. And after that, each bonding pairs holds 2 electrons. So means that you use up already 12 electrons. So minus 12. You got 36 electrons. So 36 electrons you are going to put around fluorine, with each fluorine got 3 lone pairs, just like this structure. So this is the Lewis structure for SF6. But right now, I want to determine the molecular geometry. So at the central atom, which is my sulfur, I got 6 bonding pairs without lone pair. So the total electron pair should be 6. After that, we got the class AB6 because 6 bonding pairs. After that, the basic shape name is octahedral. Same goes for the molecular geometry, and the bond angle is 90 degree. So how am I going to draw the molecular geometry right now? So in 3D drawing, we are going to start from sulfur bonded to fluorine. So this is in plane drawing. After that, towards behind, so we got dash fluorine as well, and we got wedges attached to fluorine as well. Next, don't forget, you have to put the lone pairs around the fluorine. Each of them got 3 lone pairs, just like this drawing. After that, don't forget, the last one, you have to label the bond angle. So I'm going to pick from any bonding pair. So I have this one, 90 degree. So this is the molecular geometry for SF6. So as a summary, you have to know that when we got the class AB2, the number of atoms bonded to the center is 2, and there is no lone pairs at the central atom. The arrangement of electron pairs should be linear, and the molecular geometry stays the same. When you got AB3, it is trigonal planar, AB4 is tetrahedral, AB5 is trigonal bipyramidal, and AB6 is octahedral. And you can see that this is basic shape, where there is no lone pairs at the central atom. So please remember, you have to know how to draw the correct Lewis structure, and from there we are going to take a look at the central atom only. How many bonding pairs or lone pairs for central atom has. Please complete try this 1.0 before entering my tutorial. I will see you in the next video. Bye!